All right, let me share screen. Okay, Ken. I think I forgot to give you a tick here. Yeah, this is correct. This is what is this worksheet? It's the 1.3 one, topic 1. That worksheet. Okay, this one.
Okay.
Yeah. Yes, this worksheet is fine. Okay, next worksheet I want to talk about. Homework 2, question 19A. Okay, this one. Right. Okay, so the goal of the question is to figure out what is n in terms of n. Okay. The trick here is you need to I think actually maybe you can solve for n. I'm not sure. The trick here is that the left hand side you have to filter out what is the x and what's not x. Can you see? Which ones are x? Here's a x. Here's a x. What's not x? Everything else, huh? But what happens when you got a bracket and a square? You need to times in. You need to times in. Is that clear?
Okay.
Okay. Can So that's what we're going to do. So the goal here is to make sure you get your left hand side. Rewrite it so that it's in this format. Something non-x, a non-x expression multiplied by x, then you raise it to the power of another non-x expression. Okay, and it's equal to mx power -2. How do I get that? It's because you start off with m over x squared. You bring the x squared on top, you get x power -2.
Okay.
Right? Okay, so let's begin. Let's see how we can do that. Okay, we'll work with the left-hand side. In this case, this will be equal to, let me change the font size. It will be 8 over n multiplied by 6 squared times x power 3 times 2, so 6. If you want, you can simplify straight away. That's what I'm going to do. 6 squared is really just 36. Okay, then multiply by 4 to the power of n minus 2. Just lump the n minus 2 together. Then you get 81 x squared power n minus 2. So you can sort of distribute the power. So 2n minus 4. Is this okay?
Okay.
Good. Then now you need to collect all the x and non-x. So these are all of my non-x expressions. I just have to group them together. So 8 times 36 times 4 power n minus 2 divided by n times 81 power n minus 2. Okay? And then you need to multiply by x. Oh, sorry. This x power 6 is on its own, so it's over 1. So it should appear on the numerator, x power 6. Divide by x power 2n minus 4. Is that okay?
Okay.
Good. So now we can simplify a bit more. Maybe we'll just clean this up a bit. 8 times 36, what is it equal to? 288. And everything else I just copy down. Is that okay? Okay, good. Now, can't really do much with it. I'll leave it alone. Multiply by x power 6 over 2n minus 4. So if you bring the 2n minus 4 on top, you get x power 6 minus away 2n minus 4. Bring in the minus sign. Let me just copy and paste this. Duplicate. Then we will get minus 2n plus 4. I'll skip a step. 6 plus 4 is what?
10.
10. Then I'll just remove and replace with a 10 minus 2n. Okay, Ken. So now that we got this in the following format, some non-x expression multiplied by x raised to the power of another non-x expression, we can compare with our mx power -2. Which one do you think you want to work with? The blue one first or the purple one? Which looks simpler?
Purple.
The purple one. So if we compare the purple ones, what do you notice? It's and 10 minus 2n must be equal to?
10 minus 2n must be equal to -2.
Then you can solve for n. Okay, let's see. Bring the 2n over, we get 10 plus 2 and positive 2n. So n equals to 10 plus 2, 12, divided by 2, 6. Yep. So if n equals to 6, how do we solve for m? Just compare the blue color. Do you need me to continue?
No.
Okay, then just basically sub n equal to 6 inside this guy. And then you can get your answer. Use your calculator, that's all. Okay.
Okay.
Okay, 19A done. Good. Is that all? Is that all? Can't remember. Let me check first. The rest are all fine. Oh yes, a note on faster way to do this question 5. Within this square, right, you can actually rationalize the denominator before you go and square it. Because if you look at my working, it's way shorter. Right? What I did is I took the 13 over 4 plus root 3. I rationalize it, the denominator, multiply by the conjugate top and bottom. Conjugate of the denominator. So I simplify into 4 minus square root 3. Then
Only
after
you
that,
square this.
yes, exactly. See, it's so much simpler. The numbers are so much smaller. You have to deal with 1, 6, 9, 19, 8. Eventually, you get the correct answer, but it's slower. Okay?
Okay.
Okay, yeah, just something to take note of. And also here, for this presentation, you can save some time by writing this on the left-hand side. So, I mean, this should be on your left-hand side, and then you write down equals to whatever sets you have, then equals to whatever sets you have. Then here you can leave a blank space. Here you leave a blank space, leave a blank space. Equals dot dot dot, equals dot dot dot. So it'll flow like this.
Okay.
So it's you don't have to keep on copying the same thing because you're doing nothing here, huh?
Yeah.
Just, you can save some time, huh? Don't need to repeat the same thing over and over.
Yeah.
Okay. I think something similar with the a plus b. Right? The presentation is just start from the left hand side and then equals dot 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 equals dot dot equals dot dot. So you'll flow in this direction. Anything else? Okay, that's it for this worksheet. I think there was another one. Let me find it first. Is it this one? Yes, correct. This is, what is this worksheet? Homework 3 sets end year revision. Okay, the end year revision one. Question number 5. Okay, question number 5 here. You got it. I think you got it. You see the pattern, right? 1 over square root 2 plus 3 is minus, then plus, minus, then plus, minus, then plus of the respective expression, respective term in the denominator. Can you see the pattern? Can, right? Then over here, okay, yes, you got the correct answer. You got the correct answer, but show some working. You cannot just give the final answer. Okay.
I don't know how to show.
You need to manually write it down. Every single term. This is this, this is that, that is this, this is that. Write down all of them. And then you want to add all everything together. You just write this entire thing plus, plus, plus equals to this entire thing. I wrote it over here. Then what you need to show is positive root 3, negative root 3 cancel each other off. Likewise with your root 4, root 5, root 6. Then you're left with a top top left corner and a bottom left corner. My teacher in JC used to call this Swiss cheese. You know why it's called a Swiss cheese?
Why?
Because it's like a whole block of cheese, but inside got a lot of holes. The things cancel each other off, so you're left with a 0, 0, 0. So a lot of holes inside. So it looks like a piece of cheese. Swiss cheese. You'll see this often. There's a name for this. It's called a telescoping sum. Okay, telescoping sum. It's actually in H2 max, H1 math also. And this is called the method of difference. Okay, how they would express it if this was a H2 max question, it will be like this. They will ask you to find the sum, the summation notation. If this, I don't know if it looks familiar to you. From I equals to, let me think a bit, 1 over square root of I plus square root of I plus 1. Is that okay? We're not done yet. You still need to write down the index goes from what to what. Index I goes from 2 to 6. Can you see why this is true?
Mm-hmm.
They're the same because here the pattern is there's a blue color and there's a yellow color. Square root something, square root something. And the yellow color is always one more than the left guy. Right? 3 is one more than 2. 4 is one more than 3. 5 is one more than 4. So just plus 1, plus 1. So essentially you start with I and then you end up with I plus 1. Can see the pattern?
Yeah.
Then how do I know I go from I equals to 2 to 6? Because I'm focusing on this guy. Look at the blue color, the value underneath the square root in the blue color terms. Square root 2, square root 3, square root 4, square root 5, then square root 6. So it goes from 2 to 6. That's why I write down 2 here, 6 there. Okay, so this is sigma notation. It is not in Amax, only in H1 and H2 max. Okay?
Okay.
Yeah, but yeah, yeah, the goal here is to rewrite this such that it looks like sum I equals to 2 to 6 of a difference. So in that case, in this case, it is actually minus square root I plus square root I plus 1. Okay?
Okay.
And yeah. So anyways, you always get this pattern. The in-between terms cancel each other off, left with a top left and a bottom right. I call it the top cheese and the bottom cheese because it looks like a Swiss cheese. Okay, then you just copy down. That's all. You understand this idea? Canceling?
Okay.
Yeah. You'll get to see this quite often. Anything? Oh yeah, question 8. Sorry, this is a printing error. There shouldn't be a negative there.
Okay.
Okay, there wasn't a negative. Okay, I don't want to go through this. If this I check you're working, everything is fine now. It's just that you read it wrongly, huh? Over here, it should be a positive. You can go and try again on your own. Yeah, I don't want to talk about it. You know how to solve it. Okay, then for question 12, this one you need to. Okay, let's talk about question 13 first. Just a careless mistake. Over here, it shouldn't be a 96. It should be, if I'm not wrong, minus 36. 4 times 9. That's not correct. Oh, it's 21 times 4. So it should be a 84 root 5, not 86, not 96. 21 times 4 is 84, so it should be a positive 84 root 5. Just a careless mistake here. Okay, question 13. Now talk about question 12. Let's take a look. Let me bring up the question first. I kind of forgot the question already. This is whole annual revision. Okay, let's. You have the question 12 open with you? Do you have the question 12?
Yeah.
This is the HW3 CERT's annual revision. Okay, so let's take a look. So they tell you have x1 and x2 as the roots of the quadratic equation, x squared plus x minus 1 equals to 0, and x1 is less than x2. So what does that mean? What do you need to do with this equation?
Wait, say
The
again.
quadratic equation. What do you think should be our first step? You got quadratic equation straight away. What do you do to an equation?
What do you mean?
You don't just stare at it, right? I give you an equation, you solve the equation, right or not? You solve the equation. So that's what we're going to do. X equals to negative b plus minus square root of b squared minus 4ac all over 2a. Take note that because we want an exact answer involving square roots, we cannot use the quadratic formula. Sorry, we cannot use the calculator. Must do it manually. Does that make sense?
Okay.
Okay, good. So minus minus becomes a plus, plus minus square root of b squared. I'll just use a calculator for this. Negative 1 squared minus 4 times 1 times negative 1, you get a positive 5. Or divided by 2 times 1, just a 2. Okay? Okay, good. So now we can split it up. It's really just 1 minus square root 5 over 2, or x equals 1 plus square root 5 over 2. Which one do you think is smaller? Left or right?
I think I think the left one is smaller.
Definitely, because here got minus, here got plus. Let's just, if you don't want to use a calculator, we can do it rigorously. Why should it be smaller? I think you can agree with me that this is really just 1/2 minus square root 5 over 2. This is 1/2 plus square root 5 over 2. Square root 5 is a positive number. 2 is a positive number. So square root 5 over 2 is also a positive number. Agree? Square root 5 over 2 is more than 0. Then that's really just a positive square root 5. Then if I have a negative square root 5 over 2, it must be negative, less than 0. Exactly. So what do you know about negative numbers versus positive numbers? They must be smaller lah. So in other words, negative square root of 5 over 2 must be less than positive square root 5 over 2. Agree?
Okay.
Negative is less than a positive number. Okay. Or maybe if I want to write it rigorously, it will be something like less than 0, then less than square root 5 over 2. Okay? You read it in this direction. So then what can you do now? You can ignore the 0 lah. It's really just negative square root 5 over 2 is strictly less than a positive square root 5 over 2. But there's an extra plus half, right? Can you see the plus half?
Yeah.
So you can add half to both sides of this equation. Then you get half minus square root 5 over 2 less than half plus square root 5 over 2. I'm just adding half to both sides. And there you go. You found out that this x is smaller than the other x on the right. So what can you conclude? This guy should actually be known as, the smaller one should be, this is read as less than, by the way. x1 less than x. Exactly, that's all. So this is x1 and there's x2. Okay, to be honest, you don't need to show this. It's not required. I think it's quite obvious that the minus here will tell you that it's smaller already. So x1 less than x2. So yeah, label those 1 and 2 accordingly. Then what did they tell you after that? Show that 1 over square root 3 multiplied by x1 squared times x2 is equal to 1 plus square root 5 divided by 2 root 3. How do you do a show question? Very simple. You just start from the left-hand side. For show questions, okay, I should mention this. You eventually need to learn this in trigonometry. For show questions, you're supposed to start with the left-hand side, rewrite it, copy it down first. Copy it, and then you rewrite it until you eventually get to some expression. I draw a star, and then you get stuck. Then after that, you start with the right-hand side. You copy it down, and then you equate it to something. Eventually, you need to somehow lead it up to a rectangle. You still don't know what is it, but you must eventually link it back to after a few more steps, you must link it back into the star. Must be the same here.
Okay.
Does that make sense?
Uh,
Let me show you. I think it'll be easier once I show you how to do this. So let me copy down my x1 and x2 first. Oh, sorry, are you writing something?
no.
Sorry, I didn't see. Okay, I'm just gonna move on. Yeah. So x1 and x2. Then what do we want to show? We want to show that. Let's just write down the question first. To show that 1 over the square root of 3 multiplied by x1 square times x2 is equal to 1 plus square root 5 divided by 2 root 3. So I can start with left hand side. It's equals to copy and paste, right? Copy and paste. Then I can substitute in my square root 1 and x1 and x2. So x1 squared times x2. What's my x1? I will copy and paste it over. I will use the original form. And x2 as well. Here it's already a rational denominator, so don't need to rationalize. You don't go and multiply by 1 plus square root 5 over 1 plus square root 5. We rationalize denominator. Numerator got square root is perfectly fine. Okay, 1 over square root 3, I'll leave it alone first. Then I'll square this. So 2 square, you get a 4. Then 1 minus square root 5, I'll do it at the side. In this case, it's 1 square plus root 5 square plus, sorry, it should be a minus. Minus 2 times 1 times root 5, 2 root 5. Root 5 square is just 5. 1 square is 1. 1 plus 5 is 6. 6 minus 2 root 5. 6 minus 2 root 5. I'll go a bit faster because I realize there's a common factor of 2. So I factor out the 2 to get 2 bracket 3 minus root 5. 2 bracket 3 minus root 5. Anything to cancel? Yes. The 2 and 4 cancel off. Left with 1 and a 2. Okay, then after that, you multiply by 1 plus square root 5 over 2. Simplify a bit more. So you get 1 over 2 times 2 is 4. 4 root 3 multiplied by, I'll just put it at the numerator. Okay. Okay, 3 minus root 5 multiplied by 1 plus root 5. Okay, let's simplify that. 3 times 1, 3. 3 times root 5, 3 root 5. Minus root 5 times 1, minus root 5. Minus root 5 times positive root 5, minus 5. Over 4 root 3. Simplify a bit more. I see that 3 root 5 minus root 5 becomes a 2 root 5. I see that 3 minus 5 becomes a negative 2. So I'll put it at the side here with a plus over 4 root 3. Okay, then I'm stuck. What did I want to show? I wanted to show this guy, 1 plus square root 5 over 2 root 3. But they look different. What do I do? If you can see a pattern, you'll realize that here is a 2, here is a 4.
Divide by 2.
Exactly. And here minus 2 plus 2, here 1 and 1. So I can, if let's say I didn't see that pattern, what I can do is I can start with the right hand side first. I write down 1 plus square root 5 over 2 root 3. Then I think to myself, I want this is my star. How do I get this to look like a star? Times 2, but you cannot just times 2 to the denominator on its own. You also need to multiply 2 to the numerator. Times 2, not enough. You also need to times 2 as well. Because what we are doing here is multiplying by a weird format of 1 so that they stay equal. Yeah, then after that, you eventually get back to copy and paste. Just copy and paste stuff. Answer. Right?
Wait,
Is it off? Is it wrong? Oh, it's off. This is wrong. Let me see. Did I do something wrongly?
Wait, so like for a show question, you cannot just make like work with like one side, then make it
Can as well. You can. But I want to show you an alternative method. Yes, you can do that. That's actually more, I wouldn't say it's the only way. I would say both are okay. But usually for most math questions, you'll get stuck halfway. You do until halfway and then you get stuck. You do until halfway, you get stuck. But you need to meet in the middle. Work from both directions. I think that's more efficient. Yeah. But yes, you can just work from one direction and reach the other side. But let me see what mistake I made. Did I do something wrongly here? Let's see. Please let me know if you spot my mistake. Okay. Let me see. I need a 1 plus root 5, is it? Did I? Minus 1 plus. I got a negative 1. If I times 2, it will be 2 plus 2 root 5. They are different. Here's a positive 2, here's a negative 2. Okay, sorry, I'm going to scroll up.
Okay.
I have to see my quadratic equation. Did I do something wrong? X squared plus x minus 1 equals to 0. X1 less than x2, solving for x. Negative b, oh my goodness, I see it already. The b is a positive 1, not negative 1.
Oh.
Yeah, sorry. Okay, here should be positive. Oh, luckily for me, here I'm just squaring it. And b only appears here, so I'm not affected underneath the square root. Only here it will be affected. So here is a -1 plus minus square root 5. So it's -1 minus root 5, -1 plus square root 5. The logic for this guy remains, but instead of adding a negative half, I will subtract a half. Minus half, minus half, minus half. Okay?
Okay.
Here also should be a -1/2, -1/2. I'm just going to use the original form. Okay, then -1 minus root 5 over 2 and -1 plus root 5 over 2. Let me see. Okay, so here it should be a negative sign. And then I need to restart the whole thing. Let me see if I can salvage this. Okay, I'm just gonna restart. I think it's easier.
Okay.
Yeah, sorry about that. Maybe I'll just delete the middle part here. Here is still okay. But left-hand side, I made the mistake because I substitute in the wrong x1. Then I have to restart that portion. But the denominator, yeah, I'll just restart, easier. Okay, so you want to square a fraction. Denominator have to square, you get a 4. -1 minus root 5 square, what is it equal to? Let's work it out at the side. Here, sorry, I have to change that. -1 minus root 5 bracket square. I prefer factoring out the -1, so I get 1 plus root 5. Then the whole thing square, which means a square times b square, -1 square become +1. So it's really just 1 plus square root 5 square. Right? -1 square is just +1. So +1 multiplied by 1 plus square root 5 square. So when you have minus, double negative, it's the same as changing it both to positive. So I prefer positive numbers, that's why I did that. And now I can expand this. 1 square plus 2ab plus b square. So 1 square is 1, root 5 square is 5, 1 plus 5 is 6. This is plus 2 root 5. Factor out of 2, I get 3 plus root 5. Okay?
Okay.
Then replace with 2 bracket 3 plus root 5. Again, the 2 cancels off. 1, 2. Simplify, we get 2 times 2 is 4 root 3. Oh my goodness. I'm sorry if can you hear the construction work?
I mean, it's okay.
Sorry, I can't control that. Yeah.
That's okay.
Okay, yeah. The 3 plus root 5, you multiply it by the 1 plus root 5. So you have to do it term by term. 3 times 1, 3. 3 times root 5, 3 root
Plus
5.
4 root 5.
Yeah, 1 root 5. Is it? Yeah, correct. You can just plus 1 root 5. Simplify straight away to 4 root 5, yes. And then root 5 times root 5 becomes our 5. Add together, 5 plus 3 is 8 plus 4 root 5 over 4 root 3. What happens? Maybe instead of multiplying by 2 here, I could multiply by 4. We get 8 root 3, 4 plus 4 root 5. Is that still wrong? Did I do something wrongly again? Sorry. Let me see. How can I get this right? What's the mistake here? Did I copy anything wrongly? Wait. Okay, 2 bracket 3 plus root 5, 4 and 2 cancel. 4 root 5, 3 plus 5 is 8 plus 4 root 5 over 4 root 3. Oh, right. The denominator here is what?
4.
The denominator here for the right side is what?
2 root 3
Root 3. So how do you go from 2 to 4
times 2.
times 2, top and bottom?
But it's still,
Still wrong.
yeah.
Hmm. X1 is smaller than X2, so X1 is -1 minus square root 5 divided by 2. X2 is -1 plus square root 5 divided by 2. You have 1 over square root 3 times X1 square times X2. You sub in, you get -1 minus root 5 over 2 bracket square times 1 plus root 5. Sorry, I forgot to change this part. Here, it should be a negative. Did you catch that?
No.
Here should have been a negative. Okay, I go back. Yeah, here there should have been a negative sign. I mean, do you get the mistake I made?
Oh, yeah. Okay.
Here should have been a minus, right? -1, so here is minus. Error carried forward, sorry. Okay, can. Both the X1 and X2 needs to be changed. Okay, can, understood. So let me just get rid of this old one. I think I better change the color to remind myself that it's different. Okay, -1 minus square root 5 divided by 2, -1 plus square root 5 divided by 2. So here the X2 is this guy, which means that here should be a -1. Then if you try to multiply out, let's just do it step by step in case we make any mistakes. So 2 and 4, they cancel each other off. You're left with 1, 2. That's fine. 1 times anything, you can ignore the 1. You're left with 3 plus root 5, left with -1 plus root 5. Multiply out. 3 times -1. You can ignore this 1 here, by the way. Then 3 times -1, -3. 3 times root 5, positive 3 root 5. Root 5 times -1, negative root 5. Root 5 times root 5, you get a plus 5. Here, 3 root 5 minus root 5 becomes a what? Becomes a 2 root 5. So we write it down. 2 minus 3 plus 5, positive 2. Okay, then we are done. Okay, straight away, I think I can see. No, I think you can see that there is a common factor of 2. So you can factor out, cancel them off, then you get your right hand side. Is that okay? Mic test, can you? Can? Okay, good. Then the alternative would be to times 2 over 2 on the other side. You'll get the 2 plus 2 root 5 over 2 root 3. Oh, sorry, over 4 root 3. Oh my goodness. Okay, then they will be the same.
Okay.
Yeah, so they will be the same. Okay, then next question. No, not done yet. After that, we need to simplify this expression, leaving your answer in the form of a bracket root 3 plus root 5, root b. Okay, can. Let us copy that expression down. So over here, what do we want to do? We want to simplify this fellow, right? They ask us to simplify the left-hand side, which is really just simplifying the right-hand side, right? So what do you need to do? What do you need to do?
Times root 3.
Root 3 top and bottom. Okay, so that's what we're going to do. Multiply top and bottom, get 1 plus root 3 plus root 15. Divide by root 3 times root 3 is 3. 2 times 3 is 6. Okay, we're not done yet. Oh my goodness, it's very annoying. Then you get 1/6 multiplied by square root of 3 plus square root of 15. Then we're done.
Okay.
A equals 1/6, B equals to 15. Okay, good. Finally done. Then that's it for this paper already. Time to start new topic. We will go to logarithms. Okay, I sent you a bunch of files already. My naming, I apologize, it's kind of bad. So what I did is I labeled each of them with log at the front for logarithms. Okay. Yeah. You can rename it if you want to.
Okay.
Yeah. So let's start with log 1.1 logarithms. Okay. Log 1.1. Okay. Okay. This is basically taken from a textbook. Exercise 7.1 to 7. I don't know what number. 5. We'll go through some of the questions. So before that, let's start a new page first. Let's discuss what is a logarithm. Okay, so you've already seen equations like this, right? 2 power x equal to, let's say, 8. How do you solve for x?
8 is just 2 to the power 3, x equals 3.
Yes, exactly. This is a recap on exponents. Exponential functions. Okay. Now let me ask you, if I increase the value of x here, 2 power x, right? Like say 2 power 3 versus 2 power 4 versus 2 power 5. What do you expect is the pattern? What's the trend? As you go from 2 power 3 to 2 power 5. The value will?
It will just I don't know.
Increase.
Oh, okay.
There's a trend. When you have trend questions, they are basically asking you, is it increasing or decreasing? And how fast is it increasing? Very fast. Let's not talk too much about it. Exponential growth is basically increasing very fast. Okay? It's like multiplication, it grows very fast. So it's basically increasing. So you would expect that as the power here increase, your answer gets bigger, right?
Sure.
Okay, now let's change the question. We started off with 2 power x equals to 8. Then maybe to make my presentation nicer. There's a question, that's my answer. I copy the question first, then I rewrite my 8 with 2 cubed. Comparing the power, I get x equals to 3. But now, let's say I change my answer. Change my question to 3. Don't want. Let me think a bit. 2 to the power of x equals to 9. I change my 8 to 9. Would you expect your x value to stay as 3?
No.
Or would it be bigger than 3 or smaller than 3?
I would think bigger than 3.
Must be 3 plus plus, right? Must be bigger because you're increasing from 8 to 9. As we've established, when you increase the power, the value gets bigger. Now, I'm asking in a reverse direction. If the value gets bigger, what happens to your power? Of course, it will also get bigger. So bigger than 3. But here, there's a problem. 9, is 3 square, right? Prime factorized. But is it the same as 2, the base here?
No.
No. Then can you compare? Can you conclude that x equals 2? Does it even make sense to conclude that x equals 2?
No.
Definitely not. So how do you solve for x now in this case? With this question, 2 power x equals to 9. This is when you will need, with your current knowledge. What you need now is logarithms, okay? Which is whatever I'm about to explain this topic today, or for the next few weeks, we'll be talking about logarithms. Okay, so for logarithms, the trick here is okay, wait, before I do that, I need a bit more introduction. Let's start with x squared equals to 2. How do you solve for x? Must be plus minus.
Root 2.
Square root of 2. So now, what is square root of 2? If you type in the calculator, square root of 2 is approximately
1.41 something.
414. So it goes forever, okay? It goes on forever. You cannot express it in an exact form as a fraction. That's why we call this a irrational number. But we can still, even though we cannot write out in full in decimal expansion, we still know that there's only one possible number, right? There's only, okay, two plus and minus. But there's only one such possible number, and we denote it. We come up with a new notation known as the square root, so that we can get an exact value. Does that make sense to you?
Okay.
The idea of writing out in the exact form, square root of 2. You can accept that, right? It's just a notation. The actual number is this one, 1.414, it keeps going forever. But we don't have enough time, so we don't want to write out everything. And it's not very accurate to use a approximation. So that's why we come up with something known as the square root. We come up with a new notation so that we can have the precise exact value. Does this make sense to you?
Yeah.
Okay, good. You can accept the square root. Then logarithms will also be easily understood. Here, we're going to come up with a new notation. Let's begin with the same question again. Maybe I should write down. New notation square root to get exact value. Okay, it's not exactly new to you anymore for square roots, but it's new if you are starting out. Now let's go on to logarithms. This one is definitely new. Again, I'll write down 2 power x equals to 9. But this time, how do you solve for x? By definition, it will be equals to this. log 9 base 2. I read this as logarithm of 9 base 2. Base 2. Or you can also call it logarithm, or more simply just log, because I'm lazy. Most people just call it log. Log base 2, 9 of 9. Or you can also call it log 9 base 2. Is that clear?
Okay.
Clear. Wow. Okay. Interesting. Usually students will get extremely confused.
What you mean?
What is log 9 base 2? What is log 9 base 2? How do you get the value? What is this number? Can you key in a calculator? I am not so sure. I don't think so. Sorry, let me just change my screen for a bit. I need to do a few things. Give me a second to change this. Okay, and I need to. Okay, can. Then, not done yet. Need to share screen. Oops. Share screen. Can you see my calculator?
Okay.
So this calculator, right, is this model, but it depends on, depending on your model of the calculator, you may or may not be able to key in the logarithm with the base. Here, I'm using a more modern calculator that is able to calculate this log 9 base 2. So here is the button, log with 2 spaces here, 2 blank spaces. You type in a 2 here, and you type in a 9 here. You'll get the value, 3.169.
Mine doesn't have.
Yes, most calculators
Mine is
just log, right? This calculator also has that. So my older calculator also has that. It only has this button, log or ln. Now log here and ln, they mean base 10 and base 2. And we need to use something called the change of base formula in order for us to be able to calculate the value of log 9 base 2. So let me just go back to my log 9 base 2. This is actually, if you later on, I'll teach you what it means. It's log base 10 of 9 and log base 10 of 2. So you can try typing on a calculator. Make a fraction, log. This log, by the way, means log base 10. Log here on its own is what we call the logarithm base 10. It's just a shorthand notation. Take note that log and log base 10 on its own will never be written. It has to be paired with a number all the time.
Okay.
Can. So in this case, let's say we put in a 9 there, and close the bracket, press the down, log, you press in 2, close the bracket. Okay, this is log 9 base 10 and log 2 base 10 in the calculator format. Okay, like this. All right, then press the equal. You'll get the same answer, 3.1699. Same thing as the previous one. Okay, so let's just write it down first. I'll explain later I'll explain later how we got this formula here. This is called the change of base formula. I'm not sure if I can finish explaining today. Okay, so 3.16992, so on and so forth. So again, it's just like your square root of 2, 1.414, blah, blah, blah. It has a lot of decimals, But then we are able to express it in an exact form by using a new notation, log 9 base 2. So let's just accept this for now. I will elaborate more on what this means. Let's just accept this 3.16992 for now and just check. Do we get 2 to the power of that value of x equals to 9? Let's see. Type in the calculator for me. 2 to the power of x in this case is 3.169925001. What do you get?
I get almost 9.
8.9997, almost 9, right? Here,
Yeah.
the reason why it's almost is because there's actually an infinite number of decimals on the right side. We haven't
Not
keyed in
exact.
anything. It's not exact, yes. So yeah, just keep 999. It will never reach 9. It's almost 9. So in order for us to get the exact value, we have to come up with an exact notation, which is this guy, log 9 base 2. Okay, now I'll explain how exactly did I get this notation. Before we continue, let's just do a quick exercise. Let's say, let me think a bit. Okay, not exercise. I should just give you examples. Over here, I write down again 2 power x equals to 9 now. I need to tell you some terminology. The 2 here is what we call the base. This guy here. And this x here is what we call the index. Then this 9 here is, I have no name for it. I will call it the answer. The purpose of logarithm, right, is for you to solve for the index, also known as the exponent, also known as the power.
Okay.
You write down x, then you throw the 2 over to the other side. What happens when you toss it over to the other side? The 2 will be asking for help. Oh no, it's struggling. It's struggling inside the sea of numbers. It looks very weird. Looks extremely weird. Then what does it have to do? It has to try to stay afloat. So it has to grab onto a piece of log. Have to grab onto a piece of log known as log. But it's struggling to stay afloat, so it grabs at the bottom. So you end up with log base 2. But the 9 is still there. So you just copy down the 9. And log 9 base 2.
Okay.
Does that make sense? It's just a mnemonic. Basically, this is the notation. You every time you want to solve for the unknown variable there, you want to bring the base down. The 2, you bring it down. Then in order for that base to stay afloat, it has to grab onto a piece of log. Grab onto a piece of log. Cling onto a piece of log. But the 9 will still remain. Okay? And that's the notation. Let's try a few more examples. So in this case, let's go into the questions already. Actually, maybe not so soon. Hold on. one more point I need to bring up here is that the difference between these two kinds of equations. This is what I call a polynomial equation. This is what I call an exponential equation. Can you see the difference?
Okay.
What's the difference? Focus on the left-hand side.
One where x is the base, and then the other where x is the index.
Yes, very good. Okay, yes, that's the difference. Here, when the x is the base, it's very easy. You know how to solve. Quadratic formula, everything you know how to solve already. But here, exponential form, you have to do a special trick. You need to either know that 8 is 2 cubed, and then you compare the power, or now when you cannot rewrite the 9 as a power of 2, you need to use logarithms. Okay, you need to use logarithms. Okay, let's just go straight into the question now, then you'll understand what I'm saying. So then maybe I should write down log is power. Logarithm is power. Logarithm gives you power. Like
Okay.
as in literally this math power. Okay. X is equal to a log. The power is equal to a log. Okay, let's go through some examples. So let's see, 7.1. Maybe I'll just copy down this. Okay, actually this one, let's just quickly do it. Ln 4 plus LG6. I can just key into a calculator and let you see. Ln4, close the bracket, plus LG6. And I realized that I forgot to explain to you what is Ln and LG. The answer is 2.16444. Not so important. What's more important is to know what is this notation, Ln and LG. Ln4 is actually just short form for log of 4 base E. Whereas lg of 6 is just shorthand for log of 6 base 10. Log 6 base 10.
Okay.
Ln means a base E. Do you know what is E?
No.
Do you know what's E? E is over here. Let me show you. So over here, if you press alpha and you press this button, it's this number.
Okay.
E is relevant in finance, business finance, when you are talking about compound interest and time value of money, if you've heard of those topics.
Okay.
Okay. If you are studying business, you'll definitely need to know about it. Here also eventually you need to know about it. I'll talk about it later as we go along. Okay, do you want to try, let's say, part D?
Okay.
Okay, actually, I think faster if we try together. I can type here. So LG9, do you press LOG or you press LN?
LOG.
LOG here. LOG here without a base is referring to LG. Maybe I should write this down. On a calculator, it's represented by LOG. This one represented by LN on calculator.
Yeah.
Okay, so yeah, so LOG of 9. Is that it? I'm not sure. Let's check. Minus Ln of 3, close bracket. Ln of e to the power of 2. And then you subtract 1. Okay, good. Yeah, you got it. Okay, so now you know how to calculate already. Let's move on to the next one. Maybe I should write this down. Negative 0.077844. Okay, right. Knowing the value is not important, to be honest. You just need to know how to key in the calculator. Okay, press up, then I can see my history. Then 2.16444, whatever. Oh, sorry. Let's move down here. So what is it? Determine whether log of 5 minus 2x base x is defined for the following values. So if you have x to be 0.5 over here, you need to calculate what? Let's see. Maybe I should start a new page. I need more space for some working. Okay, let's look at part A. So when x is 0.5, it will be log of base 0.5. 5 minus 2 times 0.5, base 0.5. Simplifying, I get log base 0.5 of, what is that? 5 minus 2 times 0.5. That's a 4. How do I calculate that? The trick here is to rewrite it in terms of the standard standard logarithms. It's either the LG or LG at the top and bottom, or ln at the top and bottom. And then you have the big number here in between the brackets, you put it down over here. You have the small number here at the bottom, you also put it at the bottom.
Okay.
Then you can key this into the calculator. Similarly, you can use ln. I'll just take note that LG here is represented by the LOG in the calculator.
Okay. -2.
Actually, I'm not so sure what is it. Let me just check. Oh, sorry. Let me get my charger. Uh-oh. Sorry, what's your answer?
-2.
-2. Okay, can. So what does it mean if we want to calculate this manually? Since we got a whole number, it means we can actually calculate it manually. What is log for base 0.5? Well, we can let this be equal to y. So what we have will be log of 4 base 0.5 equals y. Then by the definition of a logarithm, whenever the base here, how did it get here? It actually traveled over from the right, correct? And then it grabbed onto a log. So before that, you have to bring the 0.5 back up. So how do you do that? You just leave the 4 alone, and the 0.5 will travel over. Then you push the y up. Yes, then it becomes 0.5 power y.
Wait.
What is 0.5 power y? Let's break it around. It's really just half power y. Half is 2 power -1, right? 4 is 2 square. So how? 2 square equals to 2 power -what? Exactly what we got here. -2. Okay. So this method doesn't always work. Okay, it doesn't always work because we only got lucky here because the 1/2 can be converted into 2 power -1. The 0.5 can be written as 1/2. Okay.
Okay.
It's better to just use the calculator method. This is this formula that you did use here. It actually works in general. It's called the change of base formula. Okay, I'll just introduce it here. Change of base formula. It means that you take the logarithm of x with a base y. It will just be equals to the log of the x divided by the log of the y. And you can pick any base you like. Let's say I put a base c. The c can be any number. Okay? Yeah. Okay, let me just remove this. Pop-up display. No. Okay. Oops. Okay, let's continue. Next example, let's try another example. Let's say we try part B. Part B says x equals to 3. What happens? You'll get log of base 0.3 of 5 minus 2 times 0.3. So same thing here, you'll use the change of base formula. So it will be ln, let's say we use ln this time, of 5 minus 2 times 0.3 over 0.3. ln of 5 minus 0.2 times 0.3 over ln of 0.3. Okay, let's key it in the calculator. Fraction, ln. Then ln of, what is it? 0.3. Okay. Sorry, I made a mistake here. It should be 2 times 0.3.
And isn't it the same thing?
Oh, right. It's actually the same thing. Okay, yes, you're correct. Because I just have to divide by 10 on either guy. Yeah. Then we'll eventually get the answer. Negative 1.23. Okay.
Okay.
Can so do you need more practice for this one? The other ones? We did part A and B.
I think it's okay.
It's okay, Can. Good. So let's see. Actually, let me just read the question and see if there's any special cases that I have to take note of. Okay, let's just try one more. Part C. Part C is a little bit special. So when x is equals to 2.5, let's calculate what is the 5 minus 2x first. 5 minus 2x will be 5 minus 2 times 2.5, which is 0. So that means that we are actually calculating log of 0 base 2.5. Here, the answer will always be equals to undefined. Undefined. Okay. If you use the formula, what you will get will be ln 0 over ln 2.5 or lg. If you try to key in ln 0, type in a calculator. Let's see what happens. ln 0. Math error. Did you see that?
Okay.
Why is that the case? Because here is the ln graph. Okay, let me just introduce it now. And the exponential graph. Okay, let's take a look at the exponential graph and the logarithm graph. It's over here. There's an x, there's a y. Exponential graph looks something like this. Let's say we have y equals e power x. What is e? E again is just 2.71828, some number. Then the exponential graph will always look like this. It will start very ever so slightly above the x-axis, almost touching it but never touching it. It's very slightly hovering above, very close to the x-axis. And then it slowly increases and increases until it hits this point, 0, 1. When x is equal to 0, y will be equal to e to the power of 0, which is 1. Do you agree, this one?
Yeah.
Yeah, then after that, it will keep on increasing, and it gets faster and faster. This is called exponential growth. There's also another point that it will pass through, which is 1, e. 1, e power 1, which is just e. Can simplify as e. Yeah. 1, e. Then logarithm graph, what is it? Logarithm graph looks something like this. Y equals to the opposite of e to the power of x is actually just log x base e. Here is how the graph will look. Imagine there's a y equals to x here. Okay, this is y equal to x. We're going to reflect it about this y equals to x. Can you visualize the reflection?
Okay.
It will look something like this. Reflection means that all the x and y event essentially gets swapped around. So over here, what would the coordinates be? Make a guess. You have 0, 1, so here it will be what?
1, 0.
1, 0. And if here we have let's say this point here, the reflection, there was a 1, e, so here it will be what, 1. What do you think?
Just flip.
So this should be a e, exactly. Yes, guaranteed. Let's see if it's true. Means when x equals to e, you get y equals to 1. If x is equals to e, y equals to log of e base e. But what's log base e? It's just ln of e. Type in a calculator. ln alpha e close bracket equals. You get 1. Why is it always 1? What is log e base e. If you think about it in terms of the definition. We are basically asking you, you want to solve for y, and it is the logarithm of this e to the base e. So you can throw away the log by bringing the e back up or over and pushing the y up. Bring the y over and push the y up. So what will we get? This e here remains as the e here in light blue, but the e there in green, I will push it. I move it over and push the y up. So I'll be left with e power y. And there's an invisible one there, exactly. So therefore y is equal to 1. Make sense?
Okay.
Okay, this is just by definition. DEF with an N, definition. Definition means that you start, that is your starting point. You don't question a definition, that's your starting point. You can only build intuition behind the definition. Yeah, okay, then how about 1, 0? Means that when x is equals to 1, y will be equals to 0. But let's just sub in the x equal to 1 first. So log base e of 1, or log 1 base e. This is equal to 0. Why? Let's think about it. Do the same logic. Copy and paste it here and change it to blue. We can bring the e over, right? Then we will get e power y equals to 1. But 1 is the same as e power 0. Right or not? Yes, correct. But here 1 is equals to e power 0. Do you agree?
Okay.
So since you have the same base e, then you can now compare the power. Therefore, y is equals to 0. Does it make sense?
Yeah.
You know? Yeah. So that's why we get a y equals to 0. Okay, can equals 0. Answer.
Okay.
Can yeah, so this is the exponential graph and the logarithmic graph. But can you tell me, this logarithmic graph, what do you notice about it? Is whenever you reflect it, the exponential graph, right, is talking about how fast something is growing. So at the base here, it never touches the x-axis. But once you reflect it, this x-axis that it never touches will now become the what axis?
Y.
The y-axis, yes. This part gets reflected over here. So that means that these two graphs also never touch. What does it mean when the two graphs never touch? It means that when x is equals to 0, right? Does it ever touch the graph? Is there an intersection?
No.
So that means that whenever you try to sub in x equal to 0, it's undefined. No solution, because the two x equal to 0 is the y-axis, by the way. The y-axis and the graph never cuts each other, which means that when you sub in x equal to 0, there will be no solution. Okay?
Okay.
Likewise, when x is negative values all the way here, it never cuts the logarithm graph. The logarithm graph extends all the way down. It just keeps going down and down and down and down and down. Oh, it just keeps going down very, very close to the y-axis, but never touching it. Just like your exponential graph. Keeps going all the way to the left. Very, very close to the x-axis, but never touching it. Okay?
Okay.
So yeah, logarithm graph, you have to say that x must be more than 0. Here, there's no restriction. The x can be anything.
Okay.
Okay, good. So that's why over here it's undefined. Okay, moving on. Let's see another question. Convert each of the following to logarithmic form. I think this one is quite easy. I'll just do it at the side here. Okay, basically for this part one, you won't ever get to see this kind of question come out during exam 1. But 3 power negative 2 equals to 1/9, that's of course true. But what they want you to do is to make negative 2 the subject. So yes, you can take base 3 equals negative 2. Exactly, correct. Yes. not 1 over 9 base 3. Okay, then next one, how about 10 power n? This one more interesting, more likely to come out. It will be log of
log 10.
log 5 base 10.
Wait,
Yeah, correct. Your answer is correct. But I need you to change your way you read it out. Don't just say 10, say base 10. Base 10.
oh,
So how do you read this?
log base 10 5.
Yeah, or you can say log 5 base 10. Log base 10 of 5. Of 5. Or log 5 base 10. How about this one? 2 power x equal to p. How do you make x the subject?
Log
Log again.
base 2 of p.
Yes, very good. How about a power 3 equal to y? Let's say we make 3 the subject.
Log a. Wait,
A?
log base a of y.
Exactly. Correct. Yep. Log base a of y. Okay, then how about e power x equal to 4?
Ln 4.
Ln 4, because this is just a special base e. Okay, good. Then you can key in the calculator, but I'm not interested. Okay, moving on. Next one. Question 4. Convert each of the following to index form. What are they talking about? I am a bit confused. Okay, I believe what they want you to do is to prove that the left-hand side must be equals to the right-hand side without using a calculator. Yes, so 125 goes to 5 cube. So that means that log 125 base 5 equals to log 5 cube base 5. But remember that logarithm is asking you about the power. So how do you interpret this? How you interpret it is, I have a certain number x equals to log. Okay, maybe I should write it down. Certain number x, which is equals to log base 5 of 125. 125 will be the answer of, if I throw the 5 over, 5 power x equals to 125. So what is x? Your answer will be the answer to this logarithm question. 5 to the power of something gives me 125. But I know 125 is 5 cubed. So x is?
X is 3.
Exactly. Okay. Okay, let's phrase it again without looking at the equation. Log of 125 base 5. How do you evaluate this? Log is power. Log is power. It's asking you, you have the base 5 here. You want to raise it to a certain power question mark, such that it will become 125. There's only one correct answer. It must be 3. 5 to the power of 3 gives you 125.
Okay.
Yeah. And the 5 can cancel off, right? This is only true if this is a single base 5 and the base, the base 5 here and the base 5 here are exactly the same. That's why we call them both bases. Log base 5, this one, and the base 5 also there. So they are both called bases. But here, there's actually another rule, which is that the 3 here, you can bring it down. Okay? Yeah. Take note that this is not differentiation. This is just logarithm. You bring the 3 down. Have you learned logarithms before already?
No.
Oh, they didn't give you a crash course in JC.
I wasn't there for long enough.
Oh, okay.
I think. Yeah.
All right. And yeah, you can bring it down. This is yet another special rule later than I introduced. This is called the logarithm power rule. Do not be confused, because in the future you will learn something else that's also known as the power rule in differentiation. This one you just bring down. Okay, so 3 times log 5 base 5 is, this one is just 1, so 3 times 1, which is just equals to 3, equals to 3. Okay, I'm not going to go through part B. I think this one is a bit funny. The question, they will never ask you this kind of questions. Let's see. This one, more interesting. Ln x equal to 2. How do you make x a subject? Ln is what? Log base?
Yeah.
E. So how do you bring the base over? So how do you make x a subject? You have to bring the base over. So it's equal to, no,
Wait,
you're starting with log already. Must think the correct direction. You introduce a log if you bring the base down. Here the base is already down. You want to bring it up. So you abandon the log. Abandon the log. Exactly. You push away the 2. So e you push up. E squared. Okay, then you can also quickly check. You can check your answer just like solving the square root equation. Check. X equals e squared. So LHS is equals to ln of e squared, which is log base e of e squared. Okay, base and base same. What happens? Bring down the 2, you get log of e base e, which is 2 log of e base e. They cancel off to become a 1. 2 times 1, just a 2, which is equal to your RHS. Okay, so confirm your answer is correct. Okay, you don't need to check, no need to check. For now. In the future, there are logarithm questions that requires you to do the checking, just like your square root. All the irritating check left hand side, check right hand side. Then you need to reject some answers. Okay, Ken, next one. How about this one? Now the x is at the base. Then what do? Same thing, base bring over. Correct. Yes. Okay. Yeah, that's all there is to it. 3 equals x power 4. Then you can solve for x by taking the fourth root. Check. Check what? You haven't solved for x yet. How do you solve for x? You need to take the fourth root. So x equals to fourth root of 3, or 3 power 1 over 4. But take note that whenever you have an even number here, you need to put a plus minus. Exactly. Okay, next one. This one, let's say we make y the subject. How do we get y as a subject? Y equals base 3, bring over. Abandon the log. 3 power n. Okay, good. Ken, done.
okay.
Don't need to check. It's fine. Moving on. 5a. Given that log log x base 4 equals to 2 and log y base 2 equals to 3, evaluate x over y. How?
X equal to 4 to the power of 2. Y equals 3 power 2. Wait.
3 power 2 or 2 power 3?
2 power 3. 2 power 3.
The base stays as a base. The base 2 here, you bring to the other side, it still stays as a base. Base 2, then power 3. Okay? Yeah, so let me just write down. Yes. Yeah, it's 2, correct. This one is x power 1. Good. Correct. B is y squared, then a x y squared is just ab. Correct. Yes. This is just a and then b. So a times b. Okay, good. Next. Question 6. Without using our calculator, evaluate each of the following expressions. That's a 1. That's also a 1.
-2.
Yes. Next one. Whenever you have a 1 here, you have a base 2, you raise it to a certain power, you get 1. What is that power? 2 power something equals 1.
0. So it's just 0.
Exactly. This is just 0. Good. Plus?
Wait, sorry. Can say y is 0 again.
Okay, can.
Oh, wait.
I'll just write it down. Yeah. So let's call it x. I think it's easier that way. Then we are trying to show that x is equal to 0. Bring the 2 up. Correct or not? When you have a log and have a base 2, you carry over. The base stays as a base. So you have a base 2, but you push the x on top. So it becomes a tiny x here, equals to 1. Then I'm asking you 2 to the power of what gives you 1? 0. Okay? That's the only way. It's equal to 2 power 0. So x equals 0. Okay, yeah. So anyways, you get equals to 0 here
Equal 4.
plus yes, the log 5 base 5 is a 1. So 4 times 1 is a 4, you get 4. Next one. What's log 3 base 3?
Uh,
3 minus
3 minus 1. 4 equals
so
2
it's
cubed.
2 cube, which is 8. Okay. Next one. Now generalize. Just now you got log 4 base 4, it's a 1. Log 2 base 2, it's a 1. Log 5 base 5, it's a 1. Log 3 base 3 is a 1. Now you change to log x base x. Yes, exactly. It's still a 1. So you get 3 times 1 plus 2 over 4 minus, what's that? 2 times
0.
0. Yes. Whole thing power 2.
So every
That's
time this
75.
is 1, is always 0.
Yes. I should have started off with the summary notes, but yes, correct. Whenever the value here is a 1, then the base doesn't matter. It's always a 0.
Okay.
Yeah.
Nice.
Makes sense, right? Because let's just do a quick check. If I say let's just do a quick check why that should be the case, or why should it be a 0. So let x equal to log 1 base 5. Then just bring the base up, 5 power x equals to 1. But 1 is just 5 power 0. Then x equal to 0, exactly. Right? Okay. Okay. Let's just get the answer first. 3 times 1 is 3, 3 plus 2 is 5. 4 minus 2 times 0 is 4 minus 0, which is 4. Power 2, so 25 over 16. Okay. Next one. Log 7 base 7. Oh, is it 0? Let's check. Base 2, 6 minus 5 times 1, which is log of base, log base 2 of 6 minus 5 is a 1, which is a 0. Correct. Yes. How about LG10? What's LG10?
1.
It's 1. So 4 minus 2 times 1 is 2. Log 2 base 2, 1. Correct. Good. Okay. You understand logarithms. Starting to understand already. Now we go on to solve equations. These are the actual questions that will come up in exam. Those were all like basic practice you won't see. How do you make x a subject? 2 cube. Yes. Good. Part B, let's try. So 9 equals to x power 2. Good. Then x equals x squared equal 9. So x equal plus minus square root 9, exactly, which is a plus minus 3. How about part C? Without a calculator.
Wait.
We can do a change of base formula. Remember the formula? Change of base? Oh, you want to do that as well? Can also. Can. That works as well. Yes. 2x equals 3 over 2, then x equals to 3 over 4. I was trying to bring up the change of base formula, but it's not needed, I realized. Let's just try it instead. Let's just try it anyways. How do you use the change of base formula? I like my x on the left side, so I'm going to swap it around. What we can do is we can use a base of our choice, base of our liking. But you must remember, must be 8 on top and 4 below. A good base to choose is to prime factorize each of them first, and you realize that you can have 2 cube and 2 power 2. So it's good to choose a base of 2. You must write down the base as well. You must write down the pink color base. Then you substitute in 8 2 cube. Right? Can you see that pattern? So log base 2 of 2 cube. Then the 3 can bring down. You're left with, sorry, I never write the denominator. So 3 times of log 2 base 2. Then we work with the denominator. 4 is 2 base 2. Sorry, 2 power 2. Bring the power down. You get 2 times of log 2 base 2. Yes, you realize that they are just equal to 1. Then 3 times 1 over 2 times 1, which is just 3 over 2. This is another way to do it. Oh, but your way also works. This is also fine. Yes. I didn't think of that. Because I'm in logarithm mode already. Yeah. Can moving on.
Okay.
Next, that's this page done. Question 8. Solve each of the following equations. Should we start a new page? I think I can squeeze the working here. Let's try part A. LGX equals to 0.61. That's log base 10. So the 10 you bring up. I mean, you bring over to the other side. You abandon the log. Then what happens to your 0.61? Yes, you push it to the power. It's like a bully. The 10 is a bully. Push the 0.61 away to the top. Then you just use a calculator to calculate. Doesn't matter. Part B. Here you have a square, right? That's outside of the Ln. So you need to take the opposite of square is square root. What do you have? What do you need when you have square root in front? Plus minus. Yes. So Ln of x is the base. Then you take the square root. So plus minus square root 3. Then how? Split it up. I think it's easier. Ln x equals to negative square root 3 or Ln x equals to the positive square root 3. Then x equals to Ln is what? Base. Log x base e. So e power or x equals e power positive square root 3. Exactly. That's your answer. You can key in the calculator if you really want to find the value. Not so important. There's a bunch of numbers. Doesn't matter. Okay. Take note that it's Ln and Lg different base, so you cannot anyhow compare. Don't just conclude x equal to 2 straight away. So Ln x, maybe I just rewrite it in terms of the actual base. It will be a little bit easier to think about it. Now Lg2 actually is just a number. Just a bunch of numbers. So actually we didn't have to change this. You can just leave it as Lg2. You want to make x the subject. So who do you need to get rid of? E. So E, bring over. Yes, correct. E to the power of just a bunch of numbers, Lg2. You can check alpha E to the power of Lg2. Oh, it's just a bunch of numbers, not important. You can just use a calculator. Correct, exactly. 10 power 9 over 3. Yes. Good. Okay, let me maybe I'll skip this. You can do it already, and then I'll just move on. Okay. Skip. This one. Logarithmic form. I think they just want you to make x a subject. E bring over. So 2x equals. Yes. So half of log e base k. Okay. Should I write some working? Yeah, I should. 2x equals to ln of k lah. Log base e is just ln. Then x equals to half ln k. Then 10 power x minus 4 equals to 9. X minus 4 equals to lg of 9 base 10. Then x equals plus 4. Oh, it's not wrong to write down log base 10. Yeah, it's just lg is faster. It's allowed. It's internationally recognized notation, short form. Okay, then part C, x power 4 equals 2 minus k. So x equals fourth root of 2 minus k. Okay, 2 minus k is just a bunch of numbers.
Okay.
Then, I think that's what they're asking for. Oh, wait, maybe they're asking for logarithmic form, so they're not asking to solve for x. I think they want us to make 4 the subject. Okay, let me show you how to do that. Alternatively, 4 will be equals to log of 2 minus k base 4. Log 2 minus k base 4. Can? Oh, you don't need to put a... actually, I think it's safer to put the brackets here. Yeah. Okay, less confusion. Okay, this one I'm going to skip. Not so relevant. Let's move on. Convert to index form. Okay, can. So basically, bring the base over, bring the base over, bring the base over, bring the base over. Correct? 3 power n plus 1. Ln is base e. Next one. Log k base e. So e power, exactly, that's all. Okay, next one. Lg is base 10. So x1, correct. Yes. Next one, base 2. Yeah, then if you want to solve for y, you just divide by 4. But 4 is 2 square. Can you rewrite it as 2 power something?
Wait, sorry.
P plus 1 minus 2.
Plus 1 minus 2. P minus 1.
Yes. Okay, Ken, you got it. Okay, move on. 11. Given that you can try it again, and if you want to write it down formally, yeah. But you got the correct answer already. Okay, question 11. Given that log y of base 4 equals to a and log 2y base 8 equals to b, show that 2a equals to 3b minus 1. Okay, this one I show some working here. I think I need more space to show the working. I'll go through this. Let me start a new page. Okay, question 11. Let's start with question 11. This. Given the log of y base 4 equals to a, log 2y base 8 equals to b, you want to show 2a equals to 3b minus 1. So first we need to find out what's 2a. It's just 2 times of log y base 4. Then how about 3b minus 1? It will just be 3 times of b, which is log 2y base 8 minus 1. How in the world are they equal? How do you show that they are equal? First, you must analyze. How many terms do you see here? 1 only. Right, 1 only. How about the second guy? How many terms do you see here?
2.
2 terms. How do you? So that's the first problem you need to overcome. How come suddenly 2 terms become one term? Yes, correct. You have to make sure that the 1 and the log 8 must be combined together. So you need to rewrite it as log 8 base 8. Here there is actually a rule that is I haven't introduced yet. It's called the I don't use A and B. Cannot A and B. It's called the difference to quotient rule, or quotient to difference. Quotient difference, difference quotient. Basically, division becomes subtraction. The division and subtraction, you can remember them as both operations that will make numbers smaller. Then division, and so that's why they are related to each other. Then the thing is, the formula is log A over B base C. It's actually just log A base C, subtract away log B base C. There is an invisible pair of brackets after the minus sign. Okay? Can? And also, notice that coefficient here is a 1. 1 times log. Here also 1 times log. Over here, is it 1 times?
3.
It isn't. So that's when you need another rule, which is the power rule. Here there is a rule which is x to the power of k base c. You can just bring the k down. So it's k times of log of x base c. You can bring it down. Examples would be log base 10 of 10 power 2. It's just 2 times of log 10 base 10. It makes sense, right? This one, log base 10 of 10 is just 1. So 2 times 1 is just 2. Then here we're asking you, you got a number called 10 square, also known as 100. And you have a base 10. If you let x equals to this guy, you bring the 10 over, you are eventually getting x 10 power x equals to the 10 square. So what is x equal to? What is x equal to? 2. 2.
Yeah.
2. Yes, exactly. X is equal to 2. What is it equal to? It's equal to 2. Okay. Does that make sense? Yeah, equals to 2. So this is the rule. the power rule for logarithms. Maybe I should put this down. Power rule. Over here, even though I went forward, I brought the k down. You can always go the other direction. K you can bring up. K you can bring up. Take note that there's also an invisible pair of brackets here. Bracket here. Bracket here. So the bracket is around the 2y. So the 3 is raised to the power of 2y. In other words, this is actually log of 2y to the power of 3 base 8. Bracket, bracket around the 2y. Minus away. Oops. log of 8 base 8. Then now you can combine them as a quotient. 2y bracket bracket cube over 8. Yes, yes. Might have made this a little bit too complicated, but okay, we can still work with it. How? Now we got a single term already, but here, look at the base of the logarithms. Are they the same?
No.
Different. Then what do you do?
Yeah.
Sorry? There is another rule, if you remember. I explained it using numbers. I didn't write it properly. Sorry?
Change of base rule. No.
Yes, change of base. Correct. Change of base tells you that if you have log of let's say, I don't know, x base y. I just use different letters. P and Q, it will be log of P over log of Q. But you can choose a base. Doesn't matter. Choose C. Here, if you look at 4 and 8, I think a good number to choose here would be 2. Because 8 is 2 cubed, 4 is 2 squared. It will be easier to work with. But before we do that,
Okay.
Actually, yeah, I can. Oh, sorry. I was thinking of bringing the 2 up, become a y square. But I think there's no point to doing that. It's fine. We can leave it as a 2. Okay, let's work with this. So 2, by the way, this is your LHS. And that's your RHS. Which is why I was explaining to you just now. LHS and IHS, usually you can't just go directly. A bit difficult. It looks quite complicated. If you can go directly, you are a math wizard. I am not a math wizard. I need to do step by step. Okay. So let's choose base 2. Base 2. Y on top, 4 below. What's so special about log 4 base 2?
2.
Yeah, exactly. Good. So that means that we'll have a 2 multiplied by log y base 2 divided by 2. What happens to your 2? Cancel. So you're left with log y base 2. That looks very simple. Maybe we can convert this into a log y base 2. Maybe. It should be. Let's see how we can do that. So here, let's simplify this. Remember, our goal is to convert it into a log y base 2. Bracket around the cube, bracket around 2y, and then you have a power 3. What do you need to do? Distribute. So 8 cube. Sorry, 2 cube, which is 8, and y cube. Divide by 8. And then you take the logarithm base 8. Okay, before you take logarithm, what happens to your 8? Cancel off. So we simplify into log base 8 y cube. Still not good enough. Change of base. So what is it? Yes, correct. Good. Yes, 8 is 2 cubed. So log 2 to the power. Log 2 cube of base 2 is just 3. Let's simplify this. Wait. Let me write this down. Log y cube over log of 8. We choose base 2. Then log 8 base 2 is really just log 2 cube base 2. Bring down the power. You get log 2 base 2 with a times 3. This is a 1, so it becomes a 3. So this is just, if I simplify it down, it's just logarithm of y cube base 2 over 3. But Do you remember something about the power rule? What can you do to the power? Bring down in front. Okay. Sorry, I didn't catch it if you were saying something, writing something. Yeah, so log y base 2 with our 3 in front, then divide by 3, the 3 cancels off. And there we go, we get our log y base 2. So now, finally, we have shown that they are both equals to the same thing. Then we are done. Yay, very good. This is a standard question that will come up. Is it difficult?
No, it's just very annoying.
Okay, can. Let's just write down one more rule just to finish up this explanation. We have quotient to difference, but there is also one more. Let's just list it down. It's product to sum. Okay, product to sum rule. What does that say? It says that whenever you take the logarithm of a times b to the base c, it will just become a sum. Log a base c plus log b base c. Is that okay?
Okay.
So an example would be, let me think now. Logarithm of, let me think a bit. 4 times 8 base 2. It will be equals to log of 4 base 2 plus log of 8 base 2. You can, it's 5. What's 4 times 8?
4 times 8 is 32.
Which is 2 to the power of
5.
5. Then log, exactly. Bring the 5 down, 5 times log 2 base 2, you get a 5. Okay? Yeah, that's why it always works. And also the reason why it's 2 power 5 is because here 4 is 2 square, 8 is 2 cube. 2 square times 2 cube, you just add the power, right? So you get 2 to the power of 2 plus 3. Then if you take the log base 2 of 2 to the power of 2 plus 3, you'll cancel off the 2's. You're left with 2 plus 3.
Okay.
How do you get a 2? From here. How do you get a 3? From there. Okay, that is product to sum rule. Actually, let me just share with you the summary. If you remember, I shared with you this summary before. Can you see this? Can see?
Okay.
Indices, surds, and logarithms. Here are all the indices rules. You already learned it in Emacs. I don't want to go through. Or do you want me to go through?
I'm good.
Don't need, Okay, can. Surds also, we did a lot of practice. I think you know it by now. Square root of a product can be product of the square roots. Square root of a quotient is the quotient of the square root. Surds. Oh, you'll be seeing more surds later when you go into a topic called trigonometry. Let me show you.
God.
Not more surds.
No,
Everything.
I'm just like very annoyed by the questions because it's like, I don't know, it feels so long.
Yeah, but it's not too difficult, I hope. They didn't show the exact values. Okay, we'll talk about it
Like
eventually.
in the like triangle, then got like
the exact length. Yes, you need to involve square roots when you use Pythagoras theorem.
oh my god. Okay, whatever.
Lots of square roots. Okay, and then square root a times square root a is equal to a. Yeah, that one is okay. Logarithms, here's the rule. Here's the rules. The first one is the definition. Log y base a equals to x is equivalent to a power x equal to y. Yeah, you just bring the base over. Like base a there, you bring it over. Yeah. How do I annotate on this? Let me think a bit. Right. Hold on a second. Yeah. Okay, yes. Annotate. I'm just going to write temporary annotations. I'm not going to save this. Okay, so this is the definition. Log y base a equal to x equivalent to a power x equal to y. Basically, whenever you have a base here, the base you have to bring it over. Okay, you have to bring it over. So what you'll be left with is y equals to the a bring over, you're left with a, then power x. Okay. The a travel over, so it push the x up. So the x stays, so it travels to the top. Okay, then this one is the sum rule, product to sum rule. This one is the quotient to difference rule, difference to quotient. This one is the power rule. You bring the power down.
Okay.
And these are the two special cases that you realized. Right? Whenever it's a 1, you get a 0. Whenever they are the same, you get a 1. And here is the change of base.
Okay.
Can do you want me to prove it to you? Because so far what I've been doing is I've been telling you the formulas without explanation of why it should always be true.
Okay.
So do you want the explanation? The proof?
Anything.
Can okay, then let me just, because technically it's not required for Amex. You can just use the formula and memorize it. Do you want to understand? You wanna? No?
Okay.
Okay, good. Can let's do the explanation. Let's start a new page first. Wait, I need to change screen. Hold on a second. I can see my shared screen.
Okay.
Okay, good. So we're gonna go through the proof behind the rules. Let's go through that. So claim. First one will be LOG of base A plus LOG of base of LOG of A base C plus LOG of B base C equals to LOG of A times B base C. How do we do that? Let's see. What we can do here is we can denote this guy here as capital M, this guy here as capital N. Then in that case, what will we get? We'll get, okay, capital M equals to LOG of A base C. Then you can bring the C over. So C power M equals to LOG base A. Hey, sorry. It's just equals to A. Is that okay with you? Can A equals to C power M. So likewise, we can do the same thing with the N. You can say capital N equals to LOG B of base C. Bring the C on top. So C power N equals to B. Okay, you got expression for A. We got an expression for B.
Hi.
Is that okay?
Yep.
Can Then how about the right hand side? LOG of A times B base C. Let's calculate what is that. RHS equals to, okay, here's the proof already. Let. RHS is equal to log AB base C. What does that mean? It means we have LOG of base C of A times B, which is C power M times C power N. If you got the same base C and different power, what can you do to your power?
Power. Wait.
No. Slowly. Just exponent. Sorry.
M plus N.
M plus N, exactly. By the way, that's you cannot use power rule here because a power rule is required. This sum rule is required to prove power rule. So what you're doing is circular argument. Cannot. Power rule is intuitive, but you cannot do that. What you need to do now is
change of base rule.
Also not change of base, just definition. You let X. Okay, have I used X already? I haven't used X. Okay, good. Let X equals to this LOG C of C power M plus N. Okay. Then what can you do by the definition? Definition tells you that every time you got a log and a base, you can transfer over. What do you get?
C power X equals C M plus N. X equals to M plus N.
Exactly. So this is by definition only, no rules involved, just the very first definition, which is that LOG of, I don't know, P base Q is equal to, I don't know what's another letter after Q, R, is the same as, this is what we call equivalence, logically equivalent to P equals to Q to the power of R. Just bring the base over. Bring the base over. Okay, this is definition. Everything is built on definitions. So now, yeah, you just compare the power x equal m plus n, but x was this guy, but x is also m plus n. So we can now replace it with m plus n. But what is m? What was m?
M is log C, log base C of A.
Exactly. And of course, for n, it will be log, oops. And n was log B base C. Okay. So there we go. That's the proof. You see, I did not use any numbers at all. I just used A, B, C, and M and N. This is our math proof. If you don't like this, run away. Do not go for a university course in mathematics if you hate this. Okay?
Okay.
Yeah, this A, B, and C represent numbers that such that the logarithm is defined. That was the first one. This is the product of sum. Next one we'll go through is the difference one, difference to quotient. Let's go. So maybe I'll start a new page. One page for one rule. Okay. Next claim is if I now take the difference between them, it will become a quotient A over B. It's the exact same procedure. Proof. We let M equals to log A base C. And we also, later then I deal with it, let capital N equals to log B base C. Then you can make A the subject again, it will be C power M, B the subject again, C power N. Now we deal with the right hand side. Log A over B, base C. Sorry, do you say something?
Okay.
Oh, okay, can, good. Then replace the A with C power M, replace the B with C power N. What do you notice? Same base, different power, but you divide. What do you do with the power? Minus C power M minus N. So you get log base C of this guy. Again, you cannot use a power rule or change of base rule. You have to use definition. So we can let x be equals to log C power M minus N base C. The definition tells you. Sorry, are you confused?
No.
No. Okay. The C can bring over. So you get C power x equals to C power M minus N. Yes. Okay, good. X equal M minus N, which is, but X is just this guy. So we can call this M minus N. Okay, how do you get the minus here again? It was from this step, this key step here. When you divide exponents, you subtract the power.
Okay.
Same base, different power, divide, minus. Yeah. Okay, then log A base C. Sorry, I should leave it as M minus N first, then replace the M with, if you recall, M was log A base C. Then you subtract away the capital N, which is log, what is it? B base C, which is equal to my LHS. And then I am done. Okay, that was the logarithm rule for subtraction. Clear?
Okay.
Good. Next one, we're going to look at power rule. So over I start a new page first. Hold on a second. So just now, this was the sum to product rule. We're gonna make use of this to prove our power rule. This is what we call a theorem. Claim. I have another claim. Log A base C of power, or what's a good letter to use? I say P. It's really just P times of log A base C. Bring the power down. Okay, bring the power up. How do we do that? Well, we can just say that LHS here is equal to log A power P of base C. But what does it mean when we have A power P? Like let's say, for example, P is like 2. So it's a squared, a times a. How about if p is 3? Then it's a times a times a. If it's 4, a times a times a times a, 4 of them. P means p of them. So that means I can rewrite it as a times dot 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 times a times a. And then I just label on top here, p many. Make sense? But here, you can rewrite it as a times this bunch of a. So there's one of them, there's p minus one of them. Does it make sense?
Okay.
So now you can use this rule now. Log a b base c. You can call this as your, maybe I'll highlight it as blue color and green color. So this part would be your blue, that part would be your green. Then you can use you can make use of the rule here and split it up as log a base c plus log a times dot 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 times a base c. But now there's only p minus one of them. This one only one of them. Does that make sense? Then you can repeat the same procedure. You repeat the same procedure again. This is your blue. That is your green. Here there is only one of them. Here there's p minus two of them. Then again, you can use the sum to product rule and split it up again. So you can see, right, in general, the generalized version of this sum to product rule, if you have log of a times b times c of base, I don't know, q, then what would this be equal to? This will just be equal to the sum of each factor. Can you see the pattern?
Okay.
So for example, if you have logarithm of 10 times 100 times 1,000 base 10, it will be exactly the same as log 10 base 10 plus log of 100 base 10 plus log of 1,000 base 10. Is that clear? Are you convinced?
Okay.
This is 1, this is 2, this is 3. This one is 10 to the power of 1 plus 2 plus 3, 5. Correct? And log 10 of log base 10 of 10 power 5 is just 5, which is the same as 1 plus 2 plus 3. Sorry, this is 6. Sorry. I can't count. 6. Is this okay?
Okay.
Can okay, then in that case you can generalize further and further. This one up to p of them, you can split it up. A total of p of these log a's. Log a base c plus log a base c plus dot 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 plus log a base c. How many of them? P of them. So these are just numbers and there are p of them. Isn't that just the same as p times log a base c? Yeah, so that's how you prove it. That's the RHS. Okay. I should have put a dot 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 here. I skip a lot of steps. Here there's a p minus one of them. You still need to continue splitting up. Okay. That is the what do you call it? The power rule. What was the other rule that I had to go through? That's change of base rule. Right. Change of base. Okay. Let me see. Change of base. Let me think a little bit. Oh, right. Okay. Can. Here is the claim. If you have logarithm of a base b, change of base states that you can rewrite it as a fraction. On top there's a log, bottom there's a log as well. The big number here, the answer is a. The base here is at the denominator. Then you can choose any base you like. Let's say I put c. This will always be true. Here's a proof. We can begin by letting u equals to log a base b. Then by definition, what can we do to the base b? Bring over. What will we get?
B power u.
Equals to a. Okay, good. So that's my a. Then now what do I want to do? I want to take the logarithm base c, right? So what can I do to both sides of this equation? I can actually just log base c on both sides of the equation. Okay, so I'll get something like this. Is that clear?
Okay.
Then just now I already proved power rule, right? So I can safely use whatever I proved just now. The u can bring down. Then I'll be left with u multiplied by log b base c. Right hand side doesn't change. Okay. Then what happens now? I can make u the subject. What do I need to do?
Bring over.
Bring over, so it divides. So you get log a base c divided by log b base c. Ta-da! But what's u? U is, if you recall, it was the first guy. Then now you can replace the u with this guy, equals to log a base c divided by log b base c, which is exactly what we wanted to prove. Okay, ding, proven. Okay, then from now on, you see the proof one time, you never look at it again. Just memorize the formula and use the formula. Okay. This is in general terms. Never. So yeah. If you're interested, then you can look at the proof. If you're interested in studying math for the sake of itself, you're interested in studying pure math and becoming a researcher, then you should seriously look at this. If not, most people are gonna be engineers and just use the formula only. Just memorize formula and use it. So you don't need to look at the proof. Up to you lah. Okay. Or if you're a math major, you still need to look at the proof. Okay, so that is the change of base formula, and the rest are don't need to prove one. It's quite simple. All right, I have proven everything. Let me just label this. The names are change of base formula. Just now that one I didn't give a name. This one is called the power rule. Oh my goodness. This one is called the I don't know, difference to quotient or quotient to difference. This guy is sum to product. Okay, or product to sum. And yeah, okay, let's continue practicing questions. If you can still hear me.
Okay.
Okay, all right, let's begin. Let's continue. So this is question 12. Okay, given that log p base 3 equals to a and the log q base 27 equals to b, and p over q equals 3 power c, express c in terms of a and b. C is equals to something, a function of a and b. Okay, this is a function notation you probably never see before, but not so important. Just rewrite it in terms of a and b. How do we do that? So we need to first figure out what is C first. Which one involves C? Left, middle, right.
C equal log 3p over q.
Exactly. Okay, so we'll work with this guy and we get C equals to log P over Q base what? Base 3. Then we simplify. Oh, by the way, the subscript here, the 3 must be a subscript here. I must write it a bit below. Okay, then it's a quotient. It's a different, sorry, it's a quotient means you got division here. So we can split it up into a difference, right? But before that, make P the subject. Yes. Q equals 27 power B. Yes. Oh, you want to sub in directly? I was thinking of using, let's try something new. Let's try the quotient to difference rule. So we get log P base 3 minus away log Q base 3. Can?
Okay.
Yeah, it's over here. Okay, can yeah, then after that you can sub in your P and your Q. So what do you get? You get log of 3 power a base 3 minus away log of 27 power b base 3. This one I think can see straight away. Power rule, bring down the a. You get a multiplied by log 33, log 3 base 3. This will cancel each other off, become a 1. You're left with just a times 1, which is a. Minus. Oh, 3b? Okay. Yes, correct. Yes, 27 power b is just 3 power 3b. So it's log of 3 power 3b base 3. Then the 3b can bring down 3b times 1. Yes, just a minus 3b. Okay, good. Can. Okay, 几点了？5点半。Okay, it's already 5:30 huh? Let me see. I will assign you some homework. Later, I'll type out the questions that you should do.
Okay.
Then you can try. Actually, can I just clarify first? Let's would you be able to solve this equation?
I think
Base 2,
so.
bring over.
Yeah.
Make x a subject. Bring over. Make x a subject. Okay. Can I? All right. You will try. You will try. Then simultaneous equations. You just need to make sure you get an equation in terms of x and y, 2 of them. Over here, when you got double logarithm, it means you have to bring the base over 2 separate times. This one, ignore it. I will tell you what are the questions to do. Then the rest don't do. Okay. And then that's all for today.
Cool.
Thank you.
Cool. All right. Thank you.
Okay. Thank you. Bye bye.